Hello everyone, I welcome you all to the fourth 5G MOBIX webinar. My name is Barbara Bazdeki and I'm working in ICCS in Athens. I'm also responsible for the dissemination activities of the 5G MOBIX project. As you already know, this webinar will present the evaluation framework of the project. So, first of all, it will provide an overview of this framework and the evaluation objectives. The discussions will also include information regarding the evaluation methodology, selected KPIs, measurement tools, and data management processes. Moreover, the webinar will present the activities on assessing the potential business and societal impacts of the systems and applications demonstrated in 5G MOBIX cross-border corridors and trial sites. It will also include aspects related to the user perception of the technological advances and the corresponding acceptance of solutions. Before we start with our first speaker, I would like to inform you that we will have a questions and answers session after the presentations. So please, during the webinar, you can write your questions at the chat box and mention the name of the speaker to whom the answer is addressed to. Let me now briefly introduce you our speakers. You can find more information about them on our website. Here with us, we have Dr. Konstantinos Katsaros from ICCS, who is a project manager and senior researcher active in the areas of network function virtualization, multi-access edge computing, and software-defined networking for 5G networks. In 5G MOBIX, Dr. Katsaros acts as the leader of the evaluation activities. Ms. Marta Miranda from CTAG, Spain, is in the functional validation team working on the domain of advanced driver assistance systems and automated driving systems and connectivity. She also participates in many European and national research projects. Mr. Oscar Castañeda has been working in the mobile industry for over 20 years and he currently works in the R&D and Innovation Department at the DECRA Product Testing Service Division in Spain. He is also involved as a senior consultant in several projects. Mr. Sadek Zugari has been working in NACA Technologies for more than 15 years in data management, workflow management, architecture definition, software development, and distributed systems. He is an expert in big data, data management, and Internet of Things. In 5G MOBIX, he plays also the data manager role. Then we have Ms. Maija Federley from VTT Technical Research Center of Finland, where she works in a research group focused on foresight-driven business strategies. In our project, she leads the task on quality of life and business impact assessment. Last but not least, Mr. Emmanuel Sousa, electronic and computers engineer, who is a researcher and project manager at the Center for Computer Graphics, CCG, in Portugal. Now, I will pass the floor to Konstantinos. Konstantinos, could you please start?
Okay, hello. Let me share my face and my screen. Just, can you see my screen?
Yes.
Okay.
No, not yet. Oh, yes, I think now, yes.
Okay. Do you see my screen now?
Yes, yes.
Okay. So thank you a lot, Barbara. Thanks to all attendees for joining this webinar. I'm going to provide you an overview, a high level due to time constraints overview of the evaluation framework, and then we're going to discuss further details in individual presentations. Just as a preface to provide the context of the project.
Konstantinos, I'm sorry to interrupt you. Could you please change the mode in your presentation?
Is this okay now?
Yeah, it's fine.
Oh, okay, I'm sorry for that. Okay, so as I was saying, just to give you the context, most of you, if not all, know that 5G MOBIX is one of the ICT 18 projects focusing on cooperative and connected automated mobility applications in the context of cross-border mobility across national or international borders. At a glance, we have 2 cross-border corridors, 4 complementary European trial sites, 2 complementary Asian trial sites, lots of user stories. I will get into that. Several automated vehicles and plenty of 5G G-Node Bs. So this is a large-scale effort. Just to give you an overview regarding the cross-border corridors, we have the Spanish-Portuguese one and the Greek-Turkish one. We have local trial sites which explore aspects related to national roaming and related aspects in Finland, France, Germany, Netherlands, and we are associated also with the 2 sites in China and South Korea. Now, the overall aim of the evaluation that we are going to talk about is tailored, is focused on a series of use cases across all use case categories as defined by 3GPP: advanced driving, vehicles platooning, extended sensors, remote driving, and vehicle quality of service support. You can see the list. We don't have the time to go each one by one, but you see that we have plenty of variations of plenty of applications and variations of them to evaluate in the considered context. Now, to proceed with an overview of the evaluation framework within this project context, we have 3, let's say, threads of activity. First of all, the largest one, I would say, we have the technical evaluation, which aims to evaluate the technologies and the solutions implemented with respect to mobility, and we will see certain aspects of it. We also pay attention to impact assessment, which includes both aspects related to quality of life and business impacts, aspects related to a cost-benefit analysis for the environment we consider, and we also have aspects related to the evaluation of the user acceptance and the acceptability of the different solutions in what concerns the considered applications. Focusing now on the high-level objectives of the particular technical performance evaluation activities, we are focused on assessing the user perceived performance, exactly focusing on the applications at hand, the rich set of 24 user stories, different variations of use cases in all the cross-border and local trial sites environments. So what we pay attention at is the service continuity that we can establish or not in this cross-border or national roaming, or in general these mobile environments. And for that, we focus as a second step of further granularity. We focus on a series of impact factors with respect to service continuity and the corresponding solutions, technological solutions, which correspond themselves to deployment options like home routing versus local breakout, multi-SIM configurations, different types of handover between different versions or rollout stages of the networks, and this as a primary target, this performance is going to be assessed against identified KPI target values. I'm going to show a few KPIs indicatively later on, but at the same time, even though our primary objective is to focus on user perceived performance, we need to understand what are the baseline network performance at this environment. So we're going to perform some application agnostic measurements related to maximum capacity, so that we know how the network behaves regardless of the specificities of particular application. Now, to that end, in order to get the desired granularity, we have different layers of monitoring, of getting login information, and a segmented approach where we do not only pay attention to the end-to-end, the two application endpoints communicating and the performance of that level, but also in intermediate levels and segments of the network, so that we identify bottlenecks, potential bottlenecks. The KPIs, a series of KPIs, we have taken into account 5G PPP efforts, 3G PPP KPIs, Automotive Association KPI frameworks. More or less, these are KPIs that can be seen also in other projects. And we have identified the target KPI values for the particular use cases we focus in the project. Now, the basic, the main load of work, the main effort is focused on trials. We have some complementary simulation-based evaluation approaches that focus on aspects that cannot be investigated in the real environment. Two of them are first focused on the impact of cross-border frequency coordination approaches, where we can see different coordination schemes such as dynamic spectrum access and how this can impact the performance we perceive when crossing the borders, which is quite different from the current state of affairs. And we have also a thread of work focusing on scalability aspects, employing trace-based traffic models. So we capture traffic, we want to replay, we want to see different events, worst-case scenarios that may happen and pose different requirements from the network. Regarding the impact assessment, Maya will give you a better, a more focused idea. Just to share with you some initial metrics, we focus on costs, on revenues. We want to capture as well the quality of life in what concerns personal mobility, traffic efficiency, traffic safety, and environment aspects. What is the impact of the solutions we provide on these parameters, let's say. And of course, we have also the user acceptance metrics, which is tries to capture something that is not that easy, because it's focused on the user itself, themselves. No, it's not that technical. It's not deterministic, if we can say. So you can see several metrics, and Emmanuel later on will give you an idea of how we aim to capture these aspects, such as trust on the system regarding the perceived safety, systems usability, error tolerance, and parameters like that. So I would like to thank you. This was a brief overview. My colleagues will give you a better idea, a more focused idea on the various aspects of the evaluation framework.
Thank you very much, Konstantinos, and for keeping it in time. Thank you. So now let's hear Marta for the technical evaluation.
Okay, hello everyone, Marta Miranda. I am leading the technical evaluation in 5G MOBIX, and today I'm going to provide an overview of the test cases, templates, login information, and quality check. Okay. Okay, so this is the index of the presentation. First, I'm going to provide an overview of the technical KPIs and the relation with the cross-border issues. Secondly, the purposes of this technical evaluation, the test case description, the technical evaluation design, and finally, the measurement methodology. Okay, as commented by Dinos in the previous presentation, the goal of the technical evaluation is to analyze the impact of the cross-border mobility on the SICAN applications designed by the 2 cross-border corridors and the 6 local sites in 5G MOBIX, in particular, the effects of the roaming and handover processes. So the starting point for this technical evaluation is the definition of a set of general KPIs devoted to qualify 5G as the core connectivity infrastructure for SICAM, and also a set of Hanover KPIs that are more focused on the cross-border mobility performance. So the results of these KPIs will depend on the cross-border effects that can be gated in 4 categories: the telecommunication, the application, the security and data privacy, and also the regulation. But the ones more involved in the technical evaluation are the telecommunication and application cross-border issues. Based on this evaluation environment, a list of technical proposals is identified in order to set the basis for the technical evaluation, and also to guide the design of the test cases. For example, one of the purposes in the technical evaluation is to analyze the difference between home routing and local breakout, or analyze the impact of speed on roaming and Hanover, to analyze the transition between MECs, the difference between the infrastructure decision and the in-vehicle decision, the interoperability between devices, the cloud and MEC-based operations, the video streaming as a data flow, and so on. Okay, the previous evaluation purposes are translated into test cases. So in this way, it is defined as a common methodology in order to harmonize the design of the test cases among all the trial sites. So as it is well known, each trial site is developing its user story in the framework of the 5 use case categories of 5G MOBIX. The technical evaluation, in addition, defines the scenario as the particular variation of the user story. For example, in terms of vehicles involved in the user story, or in terms of network stressing. And we have also for each of these scenarios, we define the test cases. The test case is defined by a set of parameters that are the network configuration, the SIM that is on the user equipment, the route or the location of the test case, and the target speed of the UI. For example, in the table below, you can see an example for one of the Spanish user stories. For these user stories, we have defined 3 scenarios. The first one is the Spanish-Portuguese variant. The second one is the Spanish-Portuguese variant but stress in the network, and we have also the Netherlands variant. So for the first case, for the first scenario, the Spanish-Portuguese variant, we define the first test case with the Spanish network, a Spanish SIM, in a Spanish location and at high speeds. So this is the way we define the test cases. Okay. Regarding the design of this technical evaluation, the test cases defined by each trial sites are going to be executed repeatedly. And for each repetition, we are going to calculate these technical KPIs. So based on the results of these technical KPIs, the evaluation is going to be performing at three different levels. So the first level is the comparison between the KPI results and the target values. And this is to capture the deviation of the real results from the performance requirements. We have a second evaluation that is comparing the local KPI results with the cross-border KPI results. And in this evaluation, we are going to capture the service deterioration in the presence of the cross-border mobility and the associated Hanover roaming processes. And there is a third evaluation that is regarding the KPI results that we are going to obtain with the contribution of the local sites to the cross-border corridors. And we're going to compare these KPIs with the cross-border corridor KPI results. So in this way, we are going to be able to test additional features in the cross-border corridor environment, and also we are going to be able to align the views in 5G. This third evaluation, the extended evaluation, is the key to cover all the purposes of the technical evaluation. So, for example, we have some cases of the technical evaluation here. In the case of Finland, it's going to test the Age Discovery Service Protocol in the Spanish-Portuguese cross-border corridor. In the case of the Netherlands, they are going to test the infrastructure decision-making in the Spanish-Portuguese corridor, where they are testing the vehicle decision-making. In the case of Germany, they are going to deploy the enable extended sensors with surround view generation in the Spanish-Portuguese corridor. French and Finland are going to deploy in the Spanish-Portuguese corridor their dual SIM onboard unit solution. And finally, Finland is going to deploy in the Greece-Turkey corridor the Levis platform. Okay, so once we have defined the technical evaluation, the next step is to define the measurement methodology. So this section describes the complete flow from the collection of the raw data to the obtention of the final technical KPIs. In green, you can see the stages where we have covered so far in the project, and in orange, the ones that we are going to cover during next year, during and after the trial execution, that are the ones related with the obtention of the KPIs. The system under test. The system under test refers to the complete architecture of the user story, including the user equipments, the network, and also the ITS centers, where the PCOs, the points of control and observations, are located and organized in levels. As you know, 3 levels: access, transport, and application. And the next step is the definition of the logging measurements at these points of control and observation in order to obtain the final KPIs. So again, this logging requires a set of measurements at these 3 layers of communication, and also some UI parameters in order to identify the framework of these test cases. And finally, and as commented, the key section in the extract and transfer and load stage is the quality check process that filters the measurements that are valid for the technical evaluation. So in this case, we are going to perform a quality check at 2 levels, at trial level and also at the central test server level. In the first type of quality check, we are going to evaluate or to filter things like the common data format, the file naming, the number of logs per steps, values in runs, and we are going also to generate an output report. And for the other quality check, the one at the central test server, we are also going to test the integrity of the logs. That's all from my side. Well, thank you very much for attending.
Thank you, Marta.
Thank you.
Oscar, would you like to go on for a short preview of the preliminary Spanish and Portuguese results?
Mm-hmm. Good evening. My name is Oscar Castañeda. I work for DECRA, and we are mainly involved in evaluation activities inside the project. I'm going to tell you about some preliminary results that we have obtained in the Spanish-Portuguese corridor. Okay, so in this slide, we show you a little bit the architecture we are using for testing. In this case, what we have done by now mainly is focus on measuring the performance of the communication network. As you can see in the slide, we have the core network of both countries, Spain and Portugal, with the multi-access edge computing equipment connected very close to the base stations. We are using a non-standalone configuration with 4G and 5G, being 4G the anchor, and using 5G mainly for additional throughput and providing additional 5G capabilities. And then we have the vehicles where we install our measurement tools. And then we put some applications to perform the measurements. In this application, we install what we call agents, that are pieces of software that are also installed in other parts of the network, such as the MEC or in servers. So we transfer, we perform traffic from different points, for example, from the mobile phone to the MEC, and then we measure the different features. Okay, in this map, you see the cross-border area between Spain and Portugal, between the Spanish side and Valencia in the Portuguese side. We have two bridges, one in the highway that we call New Bridge, and an old bridge that has less traffic, and it's also for pedestrians. You can see in the top part of the image that we have two stations, as Bornetas and Centro, that provide both 4G and 5G coverage, and that coverage is what we have been measuring. Also in this image, you can see how the antennas are divided in different sectors. And so we have the As Bornetas antenna that is given coverage to the highway, to the New Bridge, and the antenna located in Centro is giving coverage to the old bridge. Also, here you also have a line of sight figure where you can see the areas in dark, so that there is no direct line of sight. So if we see As Bornetas, you can see that at least a half part of the bridge doesn't have direct line of sight, so the coverage is going to be not so good. And same happening in Centro. The line of sight is not complete in all the old bridge. So let's go to the results. We have run the routes that we saw in this map. In blue, we have the routes from Valencia to Tui, and in yellow, the routes from Tui to Valencia. The measurements that we have performed were mainly with TCP protocol, and the measurements were focused on throughput. So we measured the total throughput, the 5G new radio throughput, the LTE throughput, and we also identified the different cells and sectors inside the cell where the mobile connects to during the routes. We also record the different signal strength received by the mobile phones. In the left part of this slide, you can see some downlink throughput measurements. They are performed with two different tools. At the left, the Keysight Nemo tool, and at the right, the DECRA performance tool. First, let me say that we took these measurements just when the antennas were just installed and the configuration was still not very perfect. So you can see the throughput with red levels is not that good, but the configuration of these antennas has already been performed, and we expect to perform new measurements in October, where we should get much better results. At the right part of the slide, we have the uplink throughput, also with both measurement tools, and you can see also that the results are not that good. Okay, the previous slide was in the new bridge, and this one showed the measurements in the old bridge. And here you can see at the left side of the image, we have the downlink throughput. You can see that there is an area close to the Spanish side that the throughput is not that good. If you see at the right side of the image, we are showing the signal strength received from the 5G signal, and you can see that at that area there is no signal received at all, and that is the area where the throughput was as it was expected. And again similar, but this time with uplink throughput. Again in the same area, we got the very low or even non throughput in that part of the bridge. This going a little bit more into detail. This is the gain measurements, the same measurements as before in the case of TCP downlink. So in the graphic at the left, we are showing in green the LTE cell. In dark, we have the 5G cell. This value here means that there is no 5G coverage. And we are driving the route from Valencia and crossing the bridge up to it. As you can see at the beginning, before the bridge, there is no signal from 5G, the network RSRP, and accordingly we have no throughput. As we get into the bridge, we get these orange values that are not so good, and then the yellow values, and we see that the level is increasing. Both in blue you see the total throughput, in yellow you see the new radio throughput, and in gray the LTE throughput. And you see that all of them are going better, and there is a point that even if we have good signal, the throughput goes down. This is due to some signaling issues that we found that have been solved now. And as we continue through the bridge, we get to this area with no 5G coverage at all, and the throughput goes very, very, very low. And again, we have good coverage, and we see that both the LTE throughput and the new radio throughput goes up and up to 150 megabytes per second. So as you see, there are many things that we need to analyze to understand why we are getting better or worse results. So when we are running our use cases, we have a clear idea or where the issues may be. Okay, this is some video upload testing that we performed at the same time. The equipment was installed in a vehicle, as you can see in the top part of the slide, with 2 cameras, and then at the bottom part you can see the area with good coverage, and then the video. This is just a snapshot of the video, and we can see that the image is quite good. At the area with the coverage was not so good. We can see some distortion of the signal, as expected. Okay, so in August we have been performing additional measurements, mainly at local sites, and we have included TCP and UDP protocols, and we have performed measurements not only throughput but also one-way delay, that is latency, jitter, reliability, etc. So part of these test cases have been performed at the test track in Malaga, where there is a 5G antenna, as you can see in the top part of the left image. You can see here in these graphics that I am showing that we have got downlink throughputs up to 400 megabytes per second. In this road, you can see that we have the 5G coverage, but at some point we lost the 5G coverage and we go to only LTE. As you can see at this point, the throughput goes down. And similar results using, instead of TCP, using UDP. Again, we had the same issue that we lost the 5G coverage, and again the the throughput went down. Similar measurements, but now in the uplink, you can see that we can reach up to 20 megabits per second, but the speed is not that stable. Results are quite similar for TCP and for UDP protocols. And in this slide, I am showing some latency results. The one-way delay, that is the time that an information packet needs to go from the origin, that is from the mobile phone, to the other side of the network. That is shown in yellow. Okay, here you can see that we have at the beginning one-way delays of about 21, 22 milliseconds. In this part of the route, we have 5G coverage, and normally the delay goes, as I said, about 22 milliseconds. But at one point we lost the 5G coverage and we have only 4G, and then as you can see the delay it was increased to about 30 milliseconds. When we performed this test, we were generating traffic at a constant rate of 5 megabits per second in the uplink. You can see the receive that the throughput measured accordingly was around 5 megabits per second, but there were a couple of points that where the network was holding our packets, so the throughput went down, and suddenly the network started to deliver those packets. So the throughput for the moment increased over those 5 megabits per second. If we see the delay at that moment, you can see that the delay of those packets were delayed a lot and was about 1 second. And at this point, we have a similar effect. We also, the network again holded our packet, and the throughput went down before going up again to deliver those delayed packets. And again, the delay was increased. We also measured the packet error rate, that is the reliability of the network. You can see that during most of the route, there is no packet loss at all, but at certain points, we have little delays of about 0.1, 0.2%. Okay. I'm going to show you also some results that have been performed at the Portuguese side. The measurement performed there is quite similar. They have the vehicles where they install some pieces of software called quality of service OBU, onboard units, and in the network they also install quality of service fixed units where they have also pieces of software installed as virtual machines, and they again send traffic between this point, the OBUs and the FSUs. Here you can see the dashboard. They have a web where you can control the test cases. You can produce new test cases, change, for example, the size of the packets, the duration of the test, and establish the testing campaigns. And I have some results. You can see results obtained at the OBU side, at the vehicle side. In this case, they are UDP, and you can see throughput in the uplink and in the downlink. Similar results for TCP protocol, also throughput and transmitted bytes, also in the uplink and in the downlink. And finally, they have some results using the RTP protocol, so over the transport protocol. And here they have performed also some latency and jitter and throughput measurements. as a summary, I will say that at the Spanish side, we have performed a set of initial measurements, but the results were not as good as we wish, but we knew that because the configuration of the network was still not correct. That is something that has been solved, and new measurements are planned for October. Up to now, we have been able to measure throughput up to 450 megabits per second in the downlink and over 20 megabits per second in the uplink. In the case of the Portuguese side, the network infrastructure is still not totally ready. So the measurements performed until now have been done in 4G, and the test cases are ready and waiting for the infrastructure to be run. And that's all. I will be happy to answer your questions later.
Thank you very much, Oscar. So now Sadek will provide us with a data collection and management tools overview.
Hello, everyone. So let me. Okay, do you see my screen?
Yes.
Okay, fine. So thank you, Barbara, for presenting me. So my name is Sadek, and I work at Aka Technology. And in the context of the project, I'm playing the roles of data manager, and also I'm leading the task data collection. Okay, so the agenda that I propose here is to start with the description of the data management objective, and also highlighting the challenge and the methodologies. Then describe the data management processes that we are putting in place in the context of the project, and finally discuss and present the data collection and management tools that we are building. Okay, regarding the data management objectives that we have to develop a methodology and deliver tools for collecting and managing this data according to the evaluation requirements that we have to perform at the end of the project. For that, we need also to ensure that all the data collected are consistent across all the different trial sites. And we need to describe the tools to manage the data in different configurations at trial site level and also at centralized environment. Finally, we need to provide this data for the purpose for the global evaluation, and we need to bear in mind that we have several risks that we should take into account. First one is the loss of the test data, the providing of the data with bad formats, and finally the providing data with bad data descriptions. And we need to perform all these in compliance to the ORDP and to the RGPD. So the challenges for the data management, as I mentioned, are mainly related to the scope and to the definition of the requirements. We have different type of requirements. Requirements can be related to data measurements, related to data quality, as mentioned by Marta, but also related to the storage, the identifications of the data or the test data, and also the data provisioning of the data sharing, and finally the tools that are that we have to put in place for the data management. So against all these type of challenges, we define the different activities and tools. And first, we define a process of elicitation of the requirements. We define different processes related to the local and centralized data management. We organize different cross-workshop to synchronize and clarify test plans, test scenarios, and login measurements. And also we are identifying the measurement tools, so the synchronization approach that should be put in place in the project, defining the data models of the descriptions of this data format, data quality, and also data provisioning. Okay, here in this slide, we have a quick view showing all the requirements that are gathered from the work packages and also from ORDP, GDPR, and ethics. And on the right hand, we see the data flow where the data comes from the field, from the network, the roadside, and the vehicles. All these data are collected at trial site level in different facilities where the data quality check and data integration is performed. And finally, all the data is transferred to the centralized test server in order to be used for the evaluations on one hand, and on the other hand, to be provided for the open access. Okay, regarding the data management processes that we put in place, so we have one process defined at local trial site where we identified the data manager involved in the data collections. We identified who will store the data after the trials. We identified the tools and the servers that will be used. We identified also how and who will perform the data quality check, how the data will be transferred to the CTS, and finally how the GDPR will be, who will be in charge on this, and how this will be taken into account. At the centralized level, we also defined a data manager playing this role at the project level. We also defined the features and interfaces of a central test server. And we identified these 5 steps process where each test site, the data manager have to upload the data to the centralized test server. The test data are organized in an archive. The test data archive contains test data descriptions. This description is in XML files that should be filled by the data provider. And finally, this data descriptions contains extensive information for the identification of the test. And these smaller pictures highlight how the archive is organized with the file inside. Okay, regarding the login measurement, Marta already mentioned this, but I will concentrate my comment on this left side, where we see the process that we implemented. Here we see that the evaluation teams define the KPIs, the technical evaluation team that define the login measurement precisely. Then these informations are presented to the trial site in order to let them provide their feedback to see if the information that should be collected is feasible. And then we go back to the evaluation team and technical evaluation team to adapt these requirements. We do these cycles as needed in order to reach an agreement. Then the login measurements are published, and on the basis of this measurement, data collection, data quality tools is common data format is created and used by the data quality check to perform this validation. So now I would like to present the tools that will be used in this context. First, we have some measurement tools that need to be that we need to collect the informations at the different level as already presented. I will not go through all this information, but the slides will be available after the presentations. But what we can see is that we have some tools like the ones already mentioned by Oscar, by DECRA, where we have different agents that can be deployed in different parts of the systems. These kind of tools will enable us to collect a set of KPIs. On the other hand, we have the different other tools like KSite Nemo that will be used by some one trial site, and which will collect some measurement related to 5G, and other tools that like a PRTG that will be used for network monitoring, also associated with a set of tools. All these tools are let's say proprietary. On the other hand, we have other open source tools that will be used to build some custom solutions like iPerf, Ping, and all this list. These tools will be also used in the context of the project to gather some KPIs. I would like to highlight also one solution that will be used by one partners, and which use the Prometheus architectures, which is a server client architectures, which enable the deployment of several agents, or what we call exporters, who will collect the data, share the data in different manner with the server in order to be used for the evaluation. So, and finally, regarding the 5G chipset information that should be collected, since the tools and the drivers depend completely on the 5G chipset, each solution will use these vendors' tools. Now that we cover the measurement tools, what we are developing also in the context of the project is an integration tools that we call his data builder. These tools will be used to create the test data archive that I already mentioned by defining all the information mandatory to describe what test is performed, describing the evaluation scenario, the test scenario, which is a variation of the evaluation scenario, the data manager, the test run, and the test case ID, which gives the link with the test plan, and so on, and also the timestamps. And finally, within these integration tools, will add all the files that are collected, giving all the informations. Here's the pictures with all the metadata that will be added. Once these tools, this test data are created, the information is sent to the centralized server that we can see in this slide, where the information is uploaded. The information can be browsed, downloaded. We have some features regarding the monitoring, and also a part of the quality check, as mentioned by Marta. Here in the right hand, we see a web interface that will give access to all the data uploaded to the central servers, and here we see all the details that are associated to each test data. And finally, in this part, we see with other architectures of the centralized test server with web server and its interfaces, REST API interfaces that can be used. And on the right hand, the database, the file systems, and the ECTP server. Okay, so I hope that I give a clear view about the data management and collections, starting by the objectives and the challenges, the processes that we had to put in place, and finally the measurement tools and the data integration tools that we will use. So thank you very much, and I will be happy to answer any question you might have at the end of this presentation.
Thank you very much, Sadek. Let's move on to the next session. Maya, the floor is yours for the impact assessment.
Thank you, Barbara. Welcome to everybody to this webinar from my part as well. And I will talk a bit of different topic. I hope you can see my screen now.
Yes, it's okay.
Okay, so it's in the correct mode as well. Okay, thanks. So I'm Maya Ferele and I work as a senior scientist at VTT. And greetings from our brand new office building, VTT's office building that was taken into use 1st of September. So I'm third time here now. What I will talk about is in this presentation, I'll talk briefly about the objectives and methodologies of 5G MOBIX for impact assessment and what we will do and how we will do it. And I'll also show some preliminary intermediate outcome of our ongoing activities in business and quality of life impact assessment. And already at this point, I would like to acknowledge the contributions to quality of life impact assessment by Fanny Malin from VTT and to value network analysis by Brune Gauthier from Luxembourg Institute of Science and Technology, and contributions to CBA by Daniela Carvalho and Joana Martins from TIS Portugal. And this is the reason also that due to this short time slot that we have for the presentation and also the many excellent experts that I have in team. So I have used quite a lot of notes here during this presentation. Okay, the main objective of the impact assessment in short is to evaluate the impacts of seamless service provisioning across borders from a socio-economic perspective. So we look at the things quite on a high level in this case. And this comprises of potential impacts on quality of life in terms of personal mobility, traffic efficiency, traffic safety, and the environment. And then the evaluation of costs and benefits of 5G MOBIX solutions to assess the feasibility of these solutions and the investments that they require. And this work can be divided into 3 activities or approaches, focusing on different perspectives. And these activities are naturally linked with each other and provide inputs to each other, but to a certain extent they proceed independently. And so I have 3 topics to cover in this presentation. So first of all, the quality of life impact evaluation aims to respond to the question how 5G MOBIX systems can affect society in terms of quality of life. So what are the potential benefits for the society, and could there potentially also be some negative impacts? And then we have kind of extended a bit the original plan to cover also kind of taken also the perspective of innovation ecosystems, so that we could also identify what other types of impacts may arise in long term as a result of the project and the involvement of the ecosystem. For example, development of capabilities, new partnerships, new insight for business development, which may then in turn have an impact on innovativeness, growth, and competitiveness of a region or in a larger scale also Europe, of course. And then finally, cost-benefit analysis, CBA, or economic analysis, which gains inputs from the previous ones, that aims to respond to question, is this economically feasible? What are the costs and benefits, and how they can be monetized? And what also it helps to identify what kinds of conditions and bottlenecks may exist for the deployment of these solutions. Okay, so next I'll present the quality of life impact evaluation methodology and aims. So the cross-border services of 5G MOBIX enable seamless mobility across borders in automated vehicles, and this has potential to change travel behavior of people living or working close to a border. But however, the impact potential of the services are limited in scope and in geographical contexts. And this evaluation will focus on identifying the most important factors for each evaluation area and use case, and then on determining the likely directions of influence for each mechanism. And the methodology is based to a large part on the quality of life impact assessment carried out in Autopilot project earlier. And the main basis for the assessment is the impact assessment framework formed by the trilateral working group on automation in road transportation. The framework will be applied to 5 use cases of the project, and this approach using the framework as a basis ensures that the potential impacts will be considered systematically, including different potential impact mechanisms and both direct and indirect impacts. And we will carry out an expert assessment in this context, but that will be also supported by any other available evidence that we may have. And this diagram presents the methodology, so I'll just quickly say a few words about it. It comprises of 5 steps. Mapping of the mechanisms for the considered impact areas to the trilateral impact assessment framework, and this has been carried out with the help of literature and previous work where it has been available. And then in a second step, the mechanisms of each use case where 5G is expected to have an impact have been mapped on the trilateral impact assessment framework. And then on third step, the step 1 and 2 results will merged and to find the relevant impact mechanisms of 5G assisted automated driving for each use case and impact area. And then in step 4, data is collected and information is collected of the evidence on the potential impacts of the solutions. And the data includes pilot tests, other evaluation tasks of the project, and inputs from stakeholders and other experts and literature. And then finally, on step 5, defining the general implications of 5G on quality of life based on these results. I'll just show very quickly an example of our ongoing work without going into any details. But this gives you an idea of the impact assessment framework that we use and how it will be used. Here, as a result of the step 2 of the methodology, the impact mechanisms where 5G is expected to have an effect are shown in green and patterned boxes in the diagram. These are direct and indirect effects correspondingly. And for example, 5G enabled solutions for the use case complex maneuvers in cross-border setting is expected to have a direct effect on synchronization of speed patterns, and then indirect effect on frequency of harsh braking. And then the methodology goes on with identification of impact pathways and adding them to, and then collection of data. And then next, I'll present value network analysis, which is the approach that we use to evaluate the potential long-term business impacts that may emerge as a result of activities and learnings in this ecosystem. We will use value network analysis to investigate impacts that may be relevant from societal and business perspectives, but may remain undiscovered in the quality of life impact evaluation and cost-benefit analysis. The value network analysis considers a business model as a web of complex dynamic exchanges in the network, whereas, for example, Osterwalder's business model canvas focuses on the viewpoint of one organization. And the value network analysis methodology bases on the work of Bernale, and the visual methodology helps to create a common understanding of an economic system, and it makes visible the numerous complex relationships and tangible and intangible value objects in the ecosystem. And I'll just show again a brief example and what we are working on. And here we have used the general value network model originally outlined in the project by Catapult as a basis, and then we have adapted it here for user story 1. The stakeholders have been identified in the figure, and then the core actors have been highlighted here. And a few value exchanges between the stakeholders have been drafted in this figure. This visualization will be further refined, first based on by the impact assessment team, and then further based on the inputs from other project partners. And especially we'll still need to incorporate in this analysis the specific issues related to cross-border context, and then value objects that are more difficult to address, such as experience and reputation that may still have an impact on business in long term. And hopefully at the later stage, we'll be able to gather inputs also from some external stakeholders in the through the workshops and other events. Then still a cost-benefit analysis methodology. It aims to measure all benefits and costs of the solutions to the society in monetary terms. And the adopted methodology here bases on the Guide to CBA of Investment Project that has been published by the European Commission. In 5G MOBIX, the methodology of broadband and transport investment will be mixed to allow an overview of cost revenues and societal benefits of the two sectors. And the CBA is divided in three main areas of analysis: the financial analysis, economic analysis, and risk assessment. And you can see the indicators and topics of these areas in the figure. And then finally, the steps of the cost-benefit analysis, characterization and identification of benefits and costs, and then the collection of data for benefit estimation and deployment costs, which we work with together with work package 6 in the project, and then the analysis and key indicators. And the time horizon for the analysis we have defined as 20 years, which is the midpoint between a typical broadband project time horizon and the transport sector time horizon. We have also recognized here a risk that we may not be able to collect all enough reliable information or data to feed the CBA with the quantitative data of the benefits, for example. And in that case, we will perform a cost effectiveness analysis in the projects. So this was a really quick overview of the methodologies and topics in impact assessment area, and I thank you for your attention, and I hope to be able to answer your questions at the end of the webinar.
Thank you very much, Maya. It was very interesting. So, Emmanuel, let us know about the user acceptance.
Okay. Are you seeing my screen?
Yes, we can see your screen.
Okay, so good afternoon. My name is Emmanuel Souza, and I'll today be talking about the user acceptance evaluation that is being conducted. Sorry, you are now seeing me. But the user evaluation, the user acceptance evaluation that is being conducted in the 5G MOBIX project. So, okay, so first of all, why evaluating user acceptance? Starting by defining a bit what is this. User acceptance research aims at understanding what are the features of a new product or a new technology that make users adopt it or not. And why is this important in referring to automated driving technologies? We know that there's a huge potential for automated driving technologies to change the way we live. It can make roads more safe. It can make our transport systems more efficient in terms of the number of people transported, fuel consumption, can provide access to people with disabilities for mobility. But there are still important obstacles for this vision to realize. Some of them are technological, so we still have the things with sensors, things with artificial intelligence, telecommunications, which is the focus of the 5G MOBIX project. But as these more technical challenges are overcome, the issue of user acceptance and ensuring that the public accepts this technology becomes more pressing. So we want to promote user acceptance, and for that we need to promote both the functionality of the use cases of the technology. Users must feel it as useful and easy to use, and the feeling of trust. This is particularly true for automated driving because it's very safety critical. And it's something quite new, so people are still building their perception regarding this kind of use cases. The thing is that good impressions, and we are on the stage of developing good impressions regarding automation, can take time to develop. So, and especially with something as safety critical as automated driving. But they can be destroyed quite fast. So one bad event, one accident, a bad experience, and users and the people that will use the technology may develop a strong bias against the technology. So it becomes important that we get it right, or as right as possible in the beginning. And to ensure that, we need to evaluate the potential user acceptance as early as possible when we are developing the technologies, so that we can detect critical points of acceptance, critical issues with the technology that may make users suspicious, and address them immediately. So the 5G MOBIX project is focusing on evaluating the impact of 5G connectivity on acceptance of automated driving use cases. And it will be doing this regarding a very specific context, that is the border context. This is not quite easy because it's sometimes difficult to distinguish what is the technology from what is the overall experience of dealing with a use case of automated driving. We cannot evaluate the technology directly. So what we will be evaluating will be the acceptability of automated driving use cases, and we'll be doing that evaluation with users or potential users. And we will try to find out how those service continuity breaks that emerge on the border, on particular handover processes and difference in terms of applications, how does these processes interfere with the experience of the users and how they will affect the acceptability. So what are the challenges of this? First is that the trials in itself will offer little opportunity for the users to interact with the systems. So for safety reasons, most of the vehicle will have to be driven by professional drivers. And most of the systems are automatic, so the test users is not expected to intervene at all. And then again, it's difficult to separate what are the effects of these service continuity breaks from the user experience of the CCAM use cases. Think about, for instance, when we are using Zoom or GoToMeeting or that kind of applications at our homes, what we evaluate is the overall experience. We don't know, and what we want to separate, or making a comparison, we would like to separate what is the effect of a bad connection, like bad Wi-Fi, from what is bad design of the application by itself. And this, because we are focused here on the connection itself, that's our study object, and that's what we are trying to capture here. But people will judge the experience as a whole. So our approach will be, first we have participants, that will be the passengers of the vehicle, but not the drivers. So they will just be observers. And we'll also evaluate the acceptability of those professional and remote drivers that will be taking part, even assuming that they may be biased because they are part of the organizations that are developing these technologies. We still think that their experiences is worthwhile recording and understanding. And to make a split between what is the user experience and what is the technology causes, we will evaluate or try to evaluate the use cases in two contexts. One, in local trial, where there are no connectivity breaks, so in countries, and then with the same use cases and possibly the same users on the border where connectivity breaks and issues may occur with some frequency. And for the evaluation, we'll be using basically two methods. So one is mostly user inquiring, and this will be based on quantitative assessment through psychometric scales and some qualitative assessment through open answer questions in interviews or in focus groups, and also through observation. So we will be observing the trials and, for instance, registering events like forced takeovers during the trials that we for sure know that will cause a bad user perception. And if possible, if we can also instrument the vehicles with some cameras and also to pay attention to the behavior of the participants to see if they look at the road frequently, if they look if they have a behavior that somehow shows that they are scared or that they have some fear of something may happen. So regarding the user inquiring, we've been developing a questionnaire that is basically a psychometric scale. So what is this? We will be evaluating particular dimensions. The most basic will be what is the actual intention to use the technology. And this is evaluated by a question as simple as, if I have access to the autonomous vehicle, I intend to use it in the future. And the participants will be asked to respond on this on a scale, on a numeric scale from 1 to 5. So on 1 to 5, how much do you agree with this sentence? And then we also evaluate other dimensions, namely perceived usefulness, or how is the technology or is the use case considered useful? Again, with a similar question. And is it easy to use? Do you think that technology is relatively easy to use? And why are we evaluating these particular dimensions? Is because they are well-known causes of or hinders to acceptance in dealing with the adoption of new technologies. And because we are dealing also with automated driving, we're also focused on other dimensions like the perceived safety. Do the users feel the technology or the use case as safe? Or do they trust the technology that it will work correctly in all situations? Beyond these psychometric scales, we'll also be using interviews and focus groups with more open-answer questions. And here we intend to capture those perks of the interaction that they may have caused a positive or a negative impression or overall impression. Because the trials will only be available for a really a small group of participants, we want to also have more information. We've been developing an online assessment method that will be based, what we intend here is first to evaluate acceptability with a large pool of respondents. The thing is, how can we capture the connectivity issues of the border, all the things that happened in an online assessment, in an online questionnaire? So
Dear Emmanuel, sorry for interrupting you. Could you please conclude?
Yes, I'm finishing.
Okay, thank you.
So we'll evaluate the acceptability with a large pool of respondents by developing plausible scenarios based on like best case, worst case, and average case scenarios based on descriptions from the experts that are dealing with developing the use cases, and developing textual descriptions and animations. And each respondent will be confronted with one of these descriptions. These are some short examples of the animation. So in this case, we have the automated shuttle. It's something that the respondents will see, and then they will be asked to make an evaluation in reference to this. In this case, it's a platooning with the CYIC that is on the Greek-Turkish border. So just to conclude, we have a forced method with actual users on the road, with questionnaires with focus groups in a limited pool, and a large pool of respondents online with a questionnaire. One provides us a more in-depth perspective, while the other a more broader perspective regarding the acceptability of the use cases. And thank you very much. I'm glad to answer your questions next.
Okay, thank you very much, and sorry for the interruption. So we have all the presentations have been done, and now we have some time for questions. So I can see that we have a couple of questions for Maya. The first one is, will measured technical data from the trials be used in the impact assessment?
Yeah, this is a question that we discussed a lot in the beginning and when planning the methodology and so forth. And at this point, like presented in the presentation, we aim to use all the available data, but due to the scale of the trials that will be carried out in the project, we don't see much of the possibilities to get the evidence of the societal impacts that we aim to assess. So kind of the technical trials focus on network performance, so that's the reason that there might be difficulties in using that data. But of course, for example, from the user acceptance evaluation, we aim to look carefully if we can get any inputs from that.
Okay, thank you. And the second one for you again, Maya, is, will inputs from the actual end users be gathered for the quality of life impact evaluation?
Okay, this is basically, I can refer to Emmanuel's presentation directly, because we've tackled this or discussed the same challenges, that it's really difficult when the users don't have actual perception or experience of the services, and they don't see the whole system. So what we can do is to use the inputs from user acceptance evaluation and the questionnaires that will be done in the work package 6, and then we'll see if we can, through the focus group discussions or workshops, maybe gather some inputs from the users as well.
Okay. Oh, Maya, I see another one question for you. It says, getting an estimate for cost is very difficult. How are they addressing this?
Yeah, this is work that is now going on, and we work together with Work Package 6 deployment study, where deployment enablers to gather now. In the first phase, we gather cost data from the previous projects and literature as much as we can, but already now we know that it's not that directly applicable for our study. So then we will approach the stakeholders and try to gather from them realistic data. But that will be a challenge, and we hope for good open collaboration with and trust between in the ecosystem, so that we can get some data.
Okay, thanks again. So I see questions that maybe one of the speakers can answer it. It says, is mechanism available for senior Euro project cooperation?
Sorry, Barbara, can you repeat the question, please? If there is?
Yes. Is there a mechanism available for senior Euro project cooperation?
User project cooperation. Actually, one mechanism for cooperation in a broader sense is that of the central repository of data, in the sense that we open our measurement data and we expose this data to the public, so that people from other projects, similar projects or related projects, can get an understanding of how we reach some of our conclusions and compare against their own, if at all possible. So this is one one part of an answer. Another part of an answer is that we are in touch in general with the other ICT 18 projects. So we have open communication channels for collaboration on various fronts, and this also takes place in the context of the TMV 5G PPP working group. I don't know if any of the colleagues would like to add anything to my answer, however.
Okay. So another question also for you, Konstantinos. I think which is the time frame for the evaluation, when we will have the results?
Okay, that's the interesting part, because we have been talking, Oscar presented nice preliminary results, but still we have work to do. The plan, and we are facing also the COVID-19 problems, delays. The plan, however, is still to start with preliminary tests at the beginning of next year, and this will be followed by full-blown tests. The test cases that Marta referred to, targeting the objectives of the overall evaluation, this will hold for approximately 1 year. So we are going to have intermediate results. We are going to get back to the test beds to fix things. This is how it goes. Of course, we have the verification process at the beginning of next year. So we expect the final conclusions to be reached and to be published by the end of 2021, beginning of 2022. But
Okay.
one important aspect to add is that these evaluations are in all cases are real trials on real roads, which means we have to gain clearance for the usage of the roads. And in some cases, for instance, the Greek-Turkish corridor, we have hard borders, meaning that we have lots of bureaucratic procedures to overcome. It's not that easy to get access to the road and have our vehicles there, have the platoon be formed there for as many tests as we want. So it takes time, and this is why we estimate that for a little less than a year to complete, because we have this limitation. Apart from the large scope of the measurements, lots of objectives, lots of aspects, lots of use cases, lots of trial sites, we have a lot of work to do. But I think end of 2021, beginning of 2022, we'll have the first conclusions.
Okay, thank you very much. So I think that we are on time. I would like to remind you that the recording of the webinar will be available very soon at the project's website. And we will also upload there all the answers to the questions, including the ones that we have not answered here now. Once again, I would like to thank you all for your participation, and thank you, Ertico, for hosting the webinar one more time. Thank you all, and please stay tuned for more 5G MOBIX news. Have a nice afternoon. Bye.
Thank you all.
Thank you.
Thank you
Bye.
very much.
Thank
Bye-bye.
you. Bye-bye.
Bye-bye.
Bye-bye.